Hello, today's video lesson is going to go over a variation on a classic optimization style problem. Usually we have a fencing problem of some kind. Sometimes the fence will go along three sides. This time what we have is a fence that's going to partially form around a school block. The school block has dimensions from the picture of 70 feet by 50 feet. And then we're going to use 400 feet of fencing to wrap around a playground space. Now the design team would like to know, if you have 400 feet of fencing, how far in each direction should we go in order to optimize the amount of space that the kids have to play. So in order to do this, I'm going to spend some time just trying to understand how all the variables in the problem are related. Because what we have is the area of the playground, we have the length of the playground, and we have the width of the playground. So I'm going to draw out the two-dimensional shape, give myself a chance to see what's really going on. And then what I'm going to do is, just so I understand what's going on, I'm going to let x equal 100 feet. Just to see, like, okay, I got 400 feet of fencing, I'm going to make 100 feet this way, and then I have to figure out what the rest of them have to be. Considering the fact that if this is 100, this will be 100 minus 70, which means we'll have just 30 feet left over for the remaining horizontal side. That's how I got the calculation that there's 130 horizontal feet. Now, to get the y values, all I have to do is say, well, we have 400 feet of fencing. We're going to take away 130 feet of fencing because that was used up for the x's. And then that leaves me with 270 feet left over. Then I understand, of course, that the fencing that I have to do is one set of y fencing and another set of y minus 50 fencing. So the y plus the y minus 50 has to equal 270 feet. In other words, 2y minus 50 equals 270, 2y equals 320, y equals 160 feet. So, just to understand the nature of the problem, I've decided to follow through and calculate the area. And then I wanted to understand the algebra that went behind it. So if I make x 100 feet, I know that the area of the playground would be 12,500 square feet. I don't know if that's good or bad, but I do have that information available. And what I was able to do is to figure out the process. For example, when I took x, the next thing that I had to do was to double x and subtract 70 to get the total amount of fencing that was available for the horizontal. Then what I did was I took the 400, subtract the 130 to get the amount of fencing for y, and then I solved for y. Then to the area, I took x times y, which is the area of the entire playground and the school building, and I subtracted off the area of the school building itself, giving me a grand total. Now what I have to do is to attempt to generalize this. Instead of letting x equal 100, I'm going to let x equal x. And therefore, I have x, oops, I should change that. Give me a second. Oh, that's taking way longer than I wanted. Here we go. All I wanted to do was just write an x here. X equals x feet. Anyway, so that means my dimensions are going to be x and x minus 70, which means x plus x minus 70 is the total amount of horizontal feet used for the fencing. So the next thing I know is if I take the 2x minus 70, which is the horizontal fencing, and then I take a y and a subtraction of 50, that's going to be my total vertical fencing. That's going to be a total of 400 feet. So that enables me to solve for y in terms of x. So this situation right here, that y equals 260 minus x, is essentially the exact same thing I did here. Once I knew how much horizontal feet I was going to use, then I was easily able to figure out how much vertical feet I was going to use as well. So I just did the same thing here, except in general form. And then last time I took 100 times the 160 and subtracted 3,500. This time I'm just going to take the x and the y and then subtract the 3,500. Substitute for y, 260 minus x, and that produces a quadratic function. Now, there's lots of possibility for this function to be wrong. I could have used wrong logic, or I could have actually used wrong algebra. So I'm going to make sure that this equation does what it's supposed to do. earlier I discovered that when x is equal to 100, that the area is going to be 12,500 square feet. So my equation should be valid if when I substitute 100 in for x, I do indeed get 12,500. And that turns out to be the case. So now that I know the equation is valid, I'm going to find the maximum area, which is a vertex situation. So I find the axis of symmetry. And by the way, I just found the y value too. X is 130 and y is 130. So we want to make a square-shaped playground. And as far as area is concerned, we're going to find the area of the playground, subtract off the 3,500, and we end up with 13,400 square feet, which is almost 1,000 more square feet than I would have had if I made x equal to 100. So by making x equal to 130, I got 1,000 square feet extra playroom for the kids. I wouldn't do anything without checking with technology, so I put the equation into a technological platform and verified that the vertex is where it's supposed to be, which we can see. This matches the numbers that we just got. And then I also drew a picture of the optimal playground where x is 130 and y is 130, and then we'll have 60 and 80 respectively for the other two sides of fencing and the building block in there. So, hope this is helpful. Have a good day.